All right, here we go. First thing we'll do is we'll go over homework. Any questions on the homework? Questions on the homework? All right, let's do this real quick. Here we go. Number 2, the answer is 2 root 7. Number 4, the answer is 5 root 2. Number 6, the answer is 2 root 6. Number 8 is 2 root 30. Number 10 is 36 root 3. Number 12 is 27 root 10. Number 14 is 18. Number 16 is 70 root 3. Number 18 is 12 root 6. Number 20 is 12 root 10. Number 22 is 12 root 3. Number 24 is 44 root 3. Number 26 is 45 root 7. Number 28 is 20 root 23. And number 30 is, 25 root 82. All right, those last 3 or 4, those are kind of ridiculous. I wouldn't put something like that on a test, but it is what it is. The process is still the same. All right, I believe this is the confirmed schedule. Obviously, this week is confirmed, but next week you're going to come back on Tuesday. You're going to immediately take your PSAT test, and then we're going to roll right into Chapter 11 test. I still haven't changed this. We're not going to do 3 days, but if we do, in fact, take that test on Tuesday and there's no problems, then on Wednesday, Thursday, we'll do a Chapter 11 review. That means the Chapter 11 test should be on Friday. It should be on Friday. Okay, homework tonight's already posted. It is a worksheet. And here we go. So we're going to continue the exploration into square roots, but this time we're going to throw in some variables, all right? Throwing in some variables. So I would say that today is an easy class. You will not think it's easy until the very end when you finished it. But looking at the start, it's going to look like it's really complicated. If you printed out the worksheet, you're probably full of questions. You don't know what in the world you're supposed to be doing. Boy, will you be impressed by what you can do by the end of the class. It's pretty impressive stuff. All right, so the last few classes we've been dealing with the square root of a number, both rational and irrational numbers. So the square root of 9 is a rational number because the square root of 9 is 3. I don't need to explain why that one because we've done that so many times. Today, what we're doing is instead of it being just a number underneath the radical symbol, today there's going to be a variable to a power underneath, and you're going to have to be able to take the square root of that. Sounds complicated. Boy, is it easy. All right. What's the answer to this? Well, that's what today's class is about. So recall, the square root of 9 is 3. Now, when I first introduced this concept to you, I didn't just say memorize the square root of 9 is 3. I explained why the square root of 9 is 3. And if you remember, the explanation that I gave you was this. When you take the square root, you're basically asking yourself, what number times itself is that number that's underneath the square root symbol? So what number times itself is 9? Well, that number is 3. 3 times 3 is 9. And since you can write 3 times 3 as 3 squared, and we said before by definition that the inverse of squaring is square rooting, or the inverse of square rooting is squaring, those things that are in red right there cancel each other out. They basically undo each other. And we decided that was the reason why the square root of 9 is 3. Okay, it wasn't just something we memorized. That's the math behind it. So the square root of 9, since 3 times 3 or 3 squared is 9, then the square root of 9 is 3. Also recall this. All right, here we go. Now it's time to really pay attention. If I gave you that expression right there, x to the 5th times x to the 5th, well, if we remember the rule that says that if you have same bases and you're multiplying, then you add the exponents. So x to the 5th times x to the 5th is x to the 10th. All right, you're going to see what I'm about to say here next a whole bunch of times in this presentation. Do you see the connection between this and the previous question? Let me show you it again. All right. X to the fifth to the second power, right? Remember that rule. The power to a power rule says you're supposed to multiply. 5 times 2 is 10. Do you see it? Do you see the connection? Some of you do, but many of you probably don't see the connection. So let me beat you on the head with the information. So what does all of this mean? It means this, that x to the 10th, right, could be written as x to the 5th squared. I mean, it could be. It doesn't have to be, but it could be. X to the 5th squared. X to the 12th could be written as x to the 6th squared. X to the 8th could be written as x to the 4th squared. Do you see it? Do you see where this is going? Right? Pat yourself on the back if you can figure out what the heck's going on here. Not the answer, but why I'm showing you this and why I'm asking you, do you see it? If you don't see it, well, then I'll explain it to you. This was our original problem. What is the square root of w to the 6th power? Well, let's just back up and recall what we did when we had the square root of 9. We wrote the square root of 9 as 3 squared, and the square root and the square cancel each other out, and you're left with 3. We can do the same thing with w to the 6th power. We can do exactly the same thing, except that we're going to write w to the 6th power as something squared. Remember this slide, the previous one? We wrote each one of those, x to the 10th, x to the 12th, x to the 8th, as some number squared, x to the 5th squared, x to the 6th squared, x to the 4th squared. Why does this help us out? Is because squaring undoes square rooting, or square root undoes squaring. That's what we're going to do. So what's the big deal? The big deal is we're going to write w to the 6th power as w to the 3rd power squared. And then because squaring and square rooting cancel each other out, you're left with the answer. See how that worked? Let's do another one. You want to do w to the 8th power, you write w to the 8th as some number squared, or some variable squared in this case. Well, that would be 4, w to the 4th to the 2nd power. 4 times 2 is 8. And since squaring and square rooting cancel each other, we're left with w to the 4th. Okay, take a look at what we started with in white and what we finished with in yellow, right? Can anybody tell me a rule? Okay, what would be the rule if I took w to the 8th power? Well, what's the rule? Well, the rule is this. Write this down, please, in your notes. Is that if you take the square root of a variable to an even power, it's got to be even, it's got to be even, that all you do is take the power and divide it by 2 and you're done. You erase the square root symbol, you write the variable to the power divided by 2 if x is even. X will be even. So all you do is take half of x and you're done. Erase the square root symbol and you're done. Tonight for homework, they're going to give you the square root of a variable to an even power. Take half of it. You're done. So how do you do this? I'm taking the square root of a variable to an even power. You take half of the even power and you're done. Half of 22 is 11, so the answer is w to the 11th power. Now the middle step right there, that's just backs up why this works. Because I can write 22, or w to the 22nd power, as w to the 11th squared, square root and squaring cancel each other out. All you're going to do, if it's an even power, is take half of it. What's half of 2? Half of 2 is 1. So the answer is w to the 1st power. Now, we're kind of lazy or efficient. We leave off the 1, but it's still w to the 1st power. One more time. W to the 16th. 16 is even, so all I do is take half of it. W to the 8th. Notice I'm skipping that middle step because it's not necessary. You just take half. Erase the square root symbol. So w to the 8th. Is that all we're doing today? No. I said today would be easy. W to the 50th power. W to the 25th power. Done. I'm just taking half if x is even, and x is that power. Anybody lost? Anybody have questions? Really easy. So let's do some. W to the 6th power, take the square root of it. Take half of it, W to the 3rd. Square root of W to 28th power, take half of it, you're done. I can't make this complicated because it's not complicated. You simply take half. You simply take half. Kaylee, we good?
Yeah.
Haley?
Yeah, I'm good.
Riley?
I'm good.
Chris?
It's Piper. It won't let me change my name. I'm good.
Okay. All right. Kaylee, so what's the obvious question now?
Is there any exceptions?
Okay, so each time, what does it say? If X is even. So what's the obvious question? What's the big but?
When is it not? What happens if it isn't even?
There you go. So what happens when it's odd? It's either going to be even or odd. So that's our problem. Our next problem. And by the way, this one's just as easy. So here's how you tackle the odd ones. Well, recall that what is x to the 6th times x to the 1st? Well, the rule is if the bases are the same, you add the exponents. So that would be 6 plus 1 is 7. Oh, let me write that backwards now. So, right, do you see it? If I write it backwards, x to the 7th can be written as x to the 6th times x to the 1st. Boy, is that going to be helpful. You understand what we're about to do? What we're about to do is, instead of writing w to the 7th, I'm going to choose, kind of like what we did last night's homework, I'm going to choose, instead of writing x to the 7th, to write that, x to the 6th times x to the 1st. Why am I doing that? Because I can take the square root of w to the 6th power. The square root of w to the 6th is even, so I take half of it, right? So I take half of 6 is 3, and what I'm left with will always be w to the 1st power. I can write any odd number as an even power times x. Any odd number. I can write x to the 9th as x to the 8th times x to the 1st. So in other words, all you do is take one less than the odd number and then take half of it. Half of 8 is 4. So I get x to the 4th times the square root of x. Will it always be the square root of x if that's the variable? Yes, it will be. If it's odd, you're always going to have one left over, and that's going to stay inside the square root. We better write this down. So the second thing, if x is odd, okay, this looks way more complicated than it needs to be. All you do is the thing on the outside will be 1 less than x and then take half of it. In other words, if x is odd, subtract 1 from x and then take half. That stays on the outside. That's the power on the outside. What's on the inside will always be a to the 1st power, or just simply a. Like I said, this makes it way more complicated. Half the time, high level math, high school, college, it looks complicated and then it's explained to you. You're like, okay, that's not that complicated, but it looks complicated to write. So when x is odd, subtract 1, take half, that goes on the outside. And then what goes on the inside is just the variable all by itself, no powers. We okay, everybody?
What do you mean by, like, I understand how you have the a on the inside and like everything else on the outside, but is that like two different? Like,
Maybe
I
it'd
don't
be easier
understand
to
the
show you.
representation there.
Yeah, like I said, half the time in upper level math, the definition or the theorem or what we use to describe what it is way more complicated than when you actually do one. So hold your question. Let's just do one example. So the power there is odd. So what do? We subtract 1. 11 minus 10, or 11 minus 1 is 10, and then take half of 10. Half of 10 is 5. Half of 10 is 5. So what does it turn into? It turns into, look at what we started with and what we finished. 11 minus 1 is 10. Half of 10 is 5. And you will always have a variable on the inside to the 1st power. That's basically what it says there in blue. Subtract 1, then take half. That goes on the outside. And then the variable stays on the inside to the first power. Does that make more sense?
A little bit.
So we better do another one. So Piper, is 21 odd or even?
I don't get how you take like the inside.
Okay, well, is 21 odd or even?
Odd.
Okay, so subtract 1. What do you get?
20,
What's half of 20?
10.
So x to the 10th will be on the outside, and what's on the inside is always just the base. Look at what we started with and look at what we finished with. When the power is odd, you simply subtract 1, take half. 21 minus 1 is 20, half of 20 is 10. And then what's on the inside is just the base all by itself. Now, really, it's x to the first power. We just choose not to write to the first power. Those middle steps right there, nothing that you'll do tonight for homework. Those are just the explanation of why this works. 20 can be written as x to the 10th to the second power. Square rooting gets rid of squaring, so that would cancel out for the x to the 10th to the second power, but the x to the first power, I can't take the square root of x to the first power, so it just stays x to the first power. I couldn't tell, was that Haley or Piper that was asking the question?
Haley.
All right, Haley, let's do another one. 15, odd or even?
Odd.
Subtract 1.
14.
Half of 14.
7.
So x to the 7th is on the outside, x is on the inside. Better, or you're about the same?
Okay. It makes
Haley,
a little more sense, but
all right, well then do another one. Odd or even?
odd.
Remember, if it was even, we just take half, we're done. If it's odd, we subtract 1. 9 minus 1 is?
8.
Half of 8 is?
Take
Half of 8.
4.
So x to the 4th on the outside, x on the inside. Notice every single time we do this, you're stuck with an x, or whatever the variable is, you're stuck with an x on the inside. Technically, that's x to the first power. What's on the outside is 1 less than the original power, and then taking half. 15 minus 1 is 14, half of 14 is 7. 9 minus 1 is 8, half of 8 is 4.
Okay, that makes more sense.
Okay. Now there is one that's a little tricky. It's not really tricky, it's just weird. So what happens when you try to take, now this is just an explanation. What happens when you try to take the square root of x if we follow the rule? Well, technically x is to the first power, 1 is odd, so we're supposed to subtract 1 and then take half of it. 1 minus 1 is 0, and if we take half of 0, 0 divided by 2 is 0. And anything to the 0 power is 1. And 1 times the square root of x, 1 times anything is itself. So in fact, if you try to apply the rule, nothing changes. Look what we started with and what we finished with. This is just a long explanation of why you can't do anything with the square root of x. The square root of x is just the square root of x. As soon as you make that power anything other than 1, and then we can do something with it. But the square root of x, that's as simplified as it gets. You try to apply the rule, well, you do a whole bunch of math there and nothing happens. You kind of wasted your time. All right. One more time. Step number 1 is you figure out if the power is odd or even. Hey, 7 is odd. If it's even, you take half, done with it. If it is odd, you subtract 1. 7 minus 1 is 6. Half of 6 is 3. So 3 on the outside, W on the inside. 11 is odd. 11 minus 1 is 10. Half of 10 is 5. 5 on the outside, W on the inside. Tonight for homework, they're going to give you a combination of both odd and even. If it's even, you simply take half and you're done with it. The square root goes completely away. The odd ones are the only ones that are left with the square root symbol, and it's always the square root of whatever the variable is, x, y, z, w, whatever. You guys feel okay with this?
You went a little fast. I'm a little confused with how you got 3 and 5.
So is 7, that's the start of the problem, is 7 odd or even?
It's even.
7
No,
is
it's
odd.
It's odd.
So if it is odd, we subtract 1. 7 minus 1 is,
6.
and then half of 6 is,
Uh,
half of 6 is, half of 6 is 3. So that's why 3 is on the outside and W is on the inside. We do
okay.
the same thing with 11. 11 is odd. We subtract 1 from 11, that gives us a 10. Half of 10 is 5, so 5 on the outside. And the nice thing for this is that it's not even like we have to do anything other than remember the rule. I should have written the rule here. I have X is even there, but X is odd. We just simply need to remember the rules. So here's a mixture of both odd and even, odd and even. We'll go upper left, straight down. All right, Piper, you get the first one. Upper left, is that odd or even?
Even.
Okay, so the rule says take half of it. What's half of 8?
2.
Have your multiplication table in front of you. Half of 8 is,
4.
and that's why the answer is x to the 4th. Notice, when it's even, we get no square root of x. It's just, it goes away. All right, Haley, next one down, odd or even?
Odd.
So subtract 1, take half, what do you get?
3.
Okay, so W to the 3rd with a W on the inside, always. Kaylee, bottom one, odd or even?
That's even.
Take half.
7. So x to the 7th.
Yep, you got it. You got it. You're killing it. Haley, upper right. Tell me what to do now. Now I'm not going to say anything except what the answer is.
That's even, and that would be x to the 11th.
You got it. Piper, next one, odd or even?
Odd.
Okay, so tell me the rule.
You want to take half of it.
Subtract 1, then take half.
Okay. So it would be 16, and the half of 16 is
What times 2 is 16?
8.
There you go. And remember, for the odd ones, you're left with that square root inside. All right, Riley, last one, final answer.
X to the 6th with an X on the inside.
I told you guys would be, I mean, look what you did. You don't show this to, I don't know, an 8th grader and expect them to get anything out of this, and you guys killed it. Very good. All right. Now, the only way we make this more challenging, I mean, it's not that we make the power higher, it's just that we add an extra variable. Well, don't panic. We just treat each variable separately and follow the same rules. So it's basically 2 problems in one. So we treat each one separately. So the first one there says x to the 10th. Well, 10 is even. So half of 10 is 5. So on the outside, we get x to the 5th. Then we treat the y. Well, let's see. Y is odd. 5 minus 1 is 4. Half of 4 is 2. So you get y squared on the outside and a square root of y on the inside. You see what I did there? It's just basically 2 problems in one. It says it's more complicated, but it isn't that much more complicated. Let's see that again. Notice that the power of the x is odd. 9 minus 1 is 8. Half of 8 is 4. So we get x to the 4th on the inside, x on the inside. Y to the 8th, well, that's even. So half of 8 is 4. So we get y to the 4th on the outside. No y's on the inside. Who's lost in what I just did? All I'm doing is is that Piper?
Yeah.
So take your finger, cover up the second variable, do the first one all by itself, and then do the second one. You could, if both of those powers are odd, you can wind up with 2 variables on the inside, but that'll only happen if both powers were odd. If both powers are on the even, you're left with no square root symbol at all. Notice I got an even and an odd. So Piper, cover up the y to the 7th with your finger and just look at x to the 30th. 30 is even. So we take half of it. Half of 30 is 15. So on the outside, we get x to the 15th. Now uncover your finger and do y to the 7th. Y to the 7th is odd. So we subtract 1. 7 minus 1 is 6. Half of 6 is 3. So we get y to the 3rd with a y on the inside. Is that
Okay.
better or too fast for you?
Oh, yeah, it's better.
Okay, good. And the more of these you do, I mean, the quicker most people do these very quickly. All right. Does anybody remember when x is to the first power, what do we do? If the variable is to the first power, guess what we do?
You just leave it?
You just leave it. You do nothing, basically. So x is going to stay on the inside. The only thing I'm going to mess with now is y to the 6th. Y to the 6th is even, so we take half of it, and there you go. So if there's a variable inside to the first power, you just leave it. All right, here we go. I didn't give any of these where both of them were odd or both of them were even. Be ready for that. So the first one, let's see, 6 is even, so we take half of it. Half of 6 is 3, so we get x to the 3rd on the outside. With a y is odd, or the power is odd. 3 minus 1 is 2. Half of 2 is 1. So we get y to the 1st on the outside and a y to the 1st on the inside. I just choose not to write y to the 1st. I just write y. Stop me if you're lost. Second one variable at a time. 13 is odd. 13 minus 1 is 12. Half of 12 is 6. We get x to the 6th on the outside, x on the inside. Y to the 6th, that's even, so we take half of 6, that's 3.
Mr. Chartier,
Yes.
why is there, like, on the first problem, there's 2 y's?
There are. Remember, if I actually put a power on both of those, it would be to the first power. I just chose not to put to the first power. Well, let's think about this. 3 is odd, right? So we subtract 1. 3 minus 1 is 2. Half of 2 is 1. Does that make sense?
Yeah, but that doesn't exactly explain why there's 1 on the inside.
Why is there 1 on the inside? Why is there an x on the inside of the second one? Remember, when the power that you start with is odd, you will always wind up with one of those variables on the inside. When the power that you start with is odd, you will always wind up with that base on the inside of the first power. Does that make more sense?
So if it's odd, there's always going to be that exact same one on the inside and the outside?
Bingo. Bingo.
Okay.
And if it's even, you don't have anything. Everything will be on the outside. All right. Could it be more challenging? Yes. What they're going to do is they're going to combine yesterday's lesson with today's lesson. In other words, they're going to have numbers and variables. So all they're doing is combining yesterday's lesson with today's lesson. Okay. So we're going to treat each thing separately. So let's see. I'll do the easiest thing first, the y's. Let's see, y to the 5th power. Well, that's odd. So we subtract 1. That's y to the 4th. Half of y to the 4th is y squared. So we get y squared on the outside and a y on the inside. All I did was mess with y to the 5th. Do you see what I did? Now we mess with the 12, this homework from last night. The homework from last night was what perfect square times another number is 12? Well, that's 4 times 3. Square root of 4 is 2.
2.
So we get the final answer is that. Wait, that's not right. I left off the 3. Oops. Let me fix that. Why did I catch that this year and not last year? All right, there we go. Now it's correct. So 3y is left on the inside. Why? Because you can't take the square root of 3. It's not a perfect square. And 2y squared is on the outside. The 2 came from the square root of 4. And the y squared came from the fact that y to the 5th, subtract 1 and take half. All right, let's see if I got the second one right. B to the 4th is even. That's easy. So that's going to be half of 4 is 2. So b squared on the outside. And 32 can be written as 16 times 2. Square root of 16 is 4. So 4b squared, square root of 2. Complaints? Anybody? I'm lost. I don't know what you did there. All right, let's do a couple more. Okay, so the numbers can get larger. Don't panic. Let's see. Y to the 5th. Y to the 5th. So that's odd. So we subtract 1. That's y to the 4th. Take half of that. So that would be y squared. We said we can't do anything if the power is 1. So the square root of x is the square root of x. So y squared on the outside, y on the inside. Why? Because y to the 5th was odd, remember? Oh, look, square root of 25. That's easy. Square root of 25 is 5, so 5 goes on the outside. I said by the end of the day, we're going to be doing some impressive stuff, and we're doing it right now. I mean, look at the problem we start with, and you're actually doing this math.
I have a question. Mr. C,
I'm listening.
I'm confused why you have 5y to the second power.
What's the square root of 25?
5.
That's where the 5 came from. Where did the y squared come from? Well, that came from the fact that originally at the start of the problem, you had y to the 5th, right? 5 is odd. So the rule for odd is subtract 1. 5 minus 1 is 4. And then you take half. Half of 4 is 2. But remember, if something's odd, right, you're left with a y on the inside.
Okay, thanks.
All right. Next one there. Let's see. A squared. Oh, A, we love these one. When both of them are even, easy. They both go on the outside. Just take half. Half of 2 is 1. So you're left with an A and a B on the outside. Okay, 80 is the only one that causes us problems. I'm going to, from now on, I'm trying to get you guys to see the largest perfect square. Some of you might immediately say 4 times 20. That's fine. You can do that. But then you'd have to do, for 20, you'd have to do another 4 times 5. 16 is the largest number that goes into 80. So 16 times 5 is 80. Be ready to use the largest number. Square root of 16 is 4. So we're left with 4ab root 5. That's crazy what we just did right there. But we're just basically following those 2 rules. All right, maybe 2 more. 2 more. All right, I'll annotate this one. Oh, let's see. 6 is even. So the rule for even is we just simply take half. Half of 6 is 3. So we got y to the 3rd on the outside. Done. 28. Let's see. That's 28. 4 times 7. 4 times 7. The square root of 4. The square root of 4 is 2. So 2 goes on the outside, and you're left with 2y cubed root 7. All right, second one. Let's see. We both got an odd and an even, So let's see. The odd one, we subtract 1. 3 minus 1 is 2. Half of 2 is 1. So we got an a to the first power on the outside and an a on the inside, since it's odd. B squared, we simply take half. That's just 1. So we have a B on the outside. 45, that's 9 times 5. Remember, why is there still an A on the inside? Because for the odd ones, you're always going to be left with 1 on the inside. For the even ones, everything comes out. Square root of 9 is 3. Oh, I did it again. I left off the 5. That's 2 mistakes that I did not catch from a previous year. I want to say I've used these slides for 2 years. Maybe not. Actually, no, this is not 2 years, because last year, or the first year at school, we did not get through this chapter.
Why
Okay.
are you leaving the 5 there and not doing anything with it?
Because it's still the square root of 5, right? It's not a perfect square.
Oh, right. Okay.
So I can take the square root of 9, but it can't. Oh, by the way, I just had both of your younger siblings in my class.
Really?
Yep.
Oh, okay.
And your youngest sister looks just like Macy.
Yeah, I think
And
she does too.
is your brother older or younger than her?
He's younger.
He's
Oh
taller.
wait, no, he's then Allie, then the youngest is
Yeah.
Allie. Then it's
Oh,
Tevin,
okay,
then
okay.
it's Macy.
All right. That makes sense. He's taller
Yeah.
than Macy, though, I think.
Yeah, he is. He's almost taller than me.
All right. And he was very quiet, though. Let's just say that Allie takes after Macy.
That's
And I
funny you
said
say
that he was more like the older sister, and I said the 2 middle ones, or they're not middle ones now, but I said the two other girls are like each other.
Yeah, I
Okay,
agree.
well, that seems like that we've done a whole bunch of stuff, but we're not done yet. There's one other thing that we have to do. This is also easy, right? The previous one ends up being easy if you paid attention and you did a bunch of examples, ends up being easy. And this next thing is easy as well, too. All right, so recall that 3 squared, well, duh, that's 9, right? And that, I mean, the reason why the square root of 9 is 3 was the aforementioned that squaring gets rid of square rooting, or square rooting gets rid of squaring. But we have to be careful because there's actually 2 numbers squared that equals 9. I know I've said this before. There's actually 2 numbers that you square can give you the value 9. Well, the second number is not 3, but it's -3. If I square -3 times -3, well, I also get 9. So there ends up being 2 numbers that lead you to that value 9. And since squaring gets rid of square rooting, or square rooting gets rid of squaring, we have a problem. And the problem is this, is that when you take this, we've already had this class, is that when we take the square root of 9, that we actually potentially get 2 answers, right? The 2 answers are the square root of 9 is either 3 or it's -3. We consider the positive answer, the square root of 9 is 3, as to be the principal or the positive square root. And the square root of 9 being -3, that ends up being the negative square root. Be very careful with this. What I'm not saying is this. This one has no answer, right? There is no square root of -9 because there's no number times itself that's negative, right? The answer is not -3 here. But there are 2 numbers that when you multiply them yourself, you get to a positive 9, both 3 and -3. -3 times -3 is positive 9. 3 times 3 is 9. This becomes an issue, not next year in geometry, everything's going to be positive next year, but it becomes an issue in algebra, that when you do take the square root of a positive number, not negative, is that there are potentially 2 answers. So for instance, this problem right here, it says, what number squared is 9? Well, I know 3 squared is 9, but so is -3 squared is 9. So there's 2 possible answers to this. That becomes a problem when you're solving. When you're solving, now we're talking algebra, not geometry. When you're solving an algebraic equation, you have to include both of those answers in your final answer. Okay? We've done a bunch of equations this year. We've done linear equations. We've also done, when x is to the second power, we've done quadratic. We've also seen, we haven't done much with it, we've also seen cubic. In fact, the only time we've seen it was simply to give it a name. X to the third power is called a cubic function, right? We've seen those things. We've solved linear. We've also solved some quadratics, right? Our last chapter is solving quadratics, and a little bit of this chapter is also solving quadratics. Recall also that when we get rid of subtraction, when we're doing algebra, we add, right? That's how you get rid of subtraction. To get rid of multiplication, you divide. And we also now recall that to get rid of squaring, if I want to get rid of something that's squaring, you do the inverse, and the inverse is square rooting. What does all this mean? It means that today, the last thing we're going to do is solving equations that have the variable squared. So we're going to solve this equation right here. Well, what's attached to x? The 2 is attached to x. It's an exponent. It's to the second power. To get rid of squared, we take the square root. Whatever you do to one side, you do to the other side, and here comes the problem. The problem is that, well, there ends up being two numbers, a positive number and a negative number. So here's how we handle it in algebra. Here's the new stuff. When you get your equation down to this, where it literally says x squared is equal to some number, right? What you have to do next is when you take the square root of both sides, is on the side with the number, you got to put the symbol. I should have made it in red here. The symbol says plus or minus because there's two answers. There's the principal square root and the negative square root. Square root of x squared, 2 is even. Take half of that, it ends up being x. On the other side, though, we have to consider that the answer could be positive or negative. Square root of 9 is 3. So we get a final answer of x equals plus or minus 3. So what am I saying? I'm saying that when you have a quadratic means to the second power, and when you do your last step of an algebra problem, I got it to this stage right here. And so when I do this next step, which is take the square root of both sides, I must write next to the one with the number, I must write plus or minus. You're not going to do this with cubing. You're not going to do this when it's a linear equation, right? And it's just x by itself. The only time you're going to do this is when there's a 2 here. And guess what? There's going to be a 2 here quite frequently. So we better see a couple of examples so you catch on. By the way, how do you write the final answer? 2 ways. Either that first way in yellow, I like that. It seems to be a bit more easier. And how many people can make those? These are not parentheses, these are braces. How many people can make these braces? Most people complain about them. Either answer is fine. You'll see both answers. But a lot of people like to do the plus or minus. I'm one of them. All right, so let's solve this equation. Let's see. The first thing we need to get rid of is that 25. Let's see, to get rid of a minus 25, we add 25 to both sides. Add 25 to both sides, we get x squared equals 25. Now we got to be careful. It's a quadratic. That means it's to the second power. When we take the square root of both sides, the side that has the number, you see the 25? The side that has the number gets a plus or minus. Why? Because there's two numbers that are squared that are 25. On the left side, squaring and square rooting cancel each other out. And on the right side, you get plus or minus whatever the square root of 25 is. The square root of 25 is 5. So we get x equals plus or minus 5. That means that literally, if you throw a 5 or a negative 5 in there, it solves the equation. These can get slightly more complicated. There's just more numbers to get rid of. It's the same process. Watch. It's a 2-step equation. I need to get rid of the 2 and the 32. It's technically a 3-step because of that square. But there's two numbers I need to get rid of, the 2 and the negative 32. I'm going to choose to get rid of the negative 32 first. Get rid of minus 32 by adding 32 to both sides. Okay, that's easy. 32 and 0 is 32. The next thing, and I should have made this other than a 2, I'm going to get rid of that initial 2, not the squared, right, 2, but we're going to get rid of the coefficient 2. Well, to get rid of that 2, we divide both sides by 2. When I divide both sides by 2, let's see, the 2's would cancel, and we would be left with what? X squared equals 32 divided by 2. That's 16. Got to be careful. We've got a quadratic. When we take the square root of both sides, the number, that 16 right there gets a plus or minus. The plus or minus is on the outside, not the inside. Square rooting and square rooting cancel each other. Square root of x squared is x. It's even. Half of 2 is 1. Square root of 16 is 4. So we get x equals plus or minus 4. That means if I put a 4 or a negative 4 into that original equation, this one right here, it'll make it true. I mean, you could do a check step if you'd like. Positive 4. 4 squared is 16. 16 times 2 is 32. 32 minus 32 is 0. Negative 4. Negative 4 squared is 16. 16 times 2 is 32. 32 minus 32. Both numbers work. Okay. I only did, what, 2 examples on that. Do you have any questions? The key here is this step right here. When you get it down to that step right here, your very next step is that x is equal to plus or minus whatever the square root of that number is. Algebra 1 sometimes can be easy, sometimes it can be hard. Today was, I mean, it's challenging math, but in reality, it wasn't that bad. We did 2 things today, right? We had a radical expression that we had to simplify, 2 basic rules. 2 basic rules are, if the power is even, take half. If the power is odd, subtract 1, take half, leave one of the bases on the inside. And the last thing we did there was solve quadratic equation, right? These are called simple quadratic. We're going to get some more complicated ones next chapter. But for the simple quadratic equations, you simply, once you get to that last step where it says x squared equals a number, you say, take the square root of both sides, and you say x is equal to plus or minus whatever the square root of that number is. Will they be perfect squares? For the most part, but not always. All right, any questions on anything that we did today? Anything that we did today?
Are we able to do a couple out of the homework?
Yeah, pick one. I'll take a look. I got to pull it up, but let me stop the share here. I'll pull it up and we can do one.
Number 1.
All right, take a look at number 1. Chapter 11, worksheets. Share, because sharing's caring. All right, 288x. Hey, x is to what power?
The first power.
We do nothing with it if it's to the first power. So the final answer is going to have a square root of x in it. Absolutely. The only time you're going to mess with it if it's a number bigger than 1, right? So I know that the final answer is going to have an x in it. Maybe it has more, maybe it doesn't. All right. 288. Okay, here comes last night's homework. 288. Pick a number that you think goes into 288. That's a perfect square. This is kind of where you take a guess.
16.
Remember, the numbers you have to choose from are 1. Don't ever choose 1. 4, 9, 16, 25, 36, so forth and so on. Of those numbers, which one is the most likely to go into 288?
I want to say 16, maybe?
I don't know. Maybe it does. We'd have to do some long, but I'll just say, if you're familiar with the law of 4s, 4 goes into any number where the last 2 digits is divisible by 4. 88 is divisible by 4. So I know that 288 is divisible by 4. So let's see. 4 times what is 288? 4 times, let's see, 70. 4 goes into 28 7 times, and 4 goes in 72 times. So that's 4 times 72. I need to write this bigger. Now that might not be the final answer, but at least makes us some progress. So I know that I can write that as the square root of 4 times 72 times an x. We already know x is going to stay on the inside. So that gives me 2. Square root of 4 is 2, 72x. But wait a minute, 72 can be written as 36 times 2. And we still have that x. What's the square root of 36?
6.
Times 2.
12.
So final answer, 12. Square root of, what do we do not take the square root of the 2 and the x? All right, so that was a mean one to start off on, but that's how it's done. The key here is becoming very comfortable with these numbers right here. 1 we never consider. I mean, 1 just doesn't do anything for us. But 4, 9, 16, 25, 36. You're going to encounter these numbers so many times, though, like that 72, right? And like I said, having a basic idea of the law of 4s and the law of 9s helps as well, too. Law of 9 is you add the numbers together. If it's divisible by 9, then it's divisible. The big number is divisible by 9. But as I look at the numbers, I mean, 294. 294 is a little bit tough right there. Let's see, 2 plus 9 is 11, plus 4 is 15. So 9 doesn't go into 294. 25 doesn't. 36 might. Does 36 go into 294? Does 294 divided by
No.
36? Nope. So my next guess is, I don't know. Sometimes you can also even make your life easier. It is even. Now, square root of 2 we can't take, but we could divide 294 by 2. Maybe that gives us a 147. I'm thinking, I don't know. It's got to be an odd number. The next odd number on our list of perfect squares here is what? 36, 49. So is 294 divisible by 49?
Yes.
And there you go. I mean, that's kind of the logic, how you do those.
Mr. C,
Yeah.
when you're writing the square root symbol, do you have to put the little, like the little tiny line on the end, or can you just like down and straight back up?
I go down and straight back up. You know, technically you are supposed to put that extra little loop on it, right? Like that, but
Yeah. Okay. Just wasn't sure
all
if
right,
it really
any other
mattered.
questions? It doesn't. No, we'll know. What will matter is if you're just sloppy and you know, like that. Like, well, technically I went down and back up, but you can't really see it. So just
Yeah, okay.
exaggerate it, right? Occasionally, I don't think anyone in this class, usually it happens in 8th grade, they'll write the answer right here thinking it's long division right above it. You don't do that. I haven't seen any of you guys do that. All right, any other questions? These are pretty straightforward. None of them aren't necessarily hard. Oh, and by the way, here are the answers. Okay, well, that kind of does it for today. We finished with about 2 minutes left. You guys have a wonderful day, and I will see you guys tomorrow.
Bye.
You too. Bye.
See ya.